Okay, guys, this is revision before the examination for exponential and logarithm functions. Okay, first, let's see some paper 1 questions. Okay, in paper 1 questions, we can't use calculator. Okay, so you see there are a few questions about solving exponential equations. Okay, so if you want to look back for what we've learned, you can go back to the PowerPoint about the exponential equations. So normally there are a few techniques you need to learn before the examination, right? And the first technique is what we call common base technique, which you need to get the both sides using the common base, and then you compare their indices, all right? And some of them are quite trivial, like the example 1, all right? But some of them could be a bit challenging. Okay, it depends on whether you need to use the index law to convert the term into certain power form, and sometimes you have to use negative power. Okay, so let's see the first few questions. Okay, so the first question, 2 to the power x minus 2 equals 4 to the power x. So obviously, we see that's the number 2 here and the number 4. Okay, they should have a common base in 2, all right? So we don't need to do anything on the left-hand side, but on the right-hand side, you might need to rewrite that 4 into 2 to the power 2, which is 2 squared. All right, then you use the index law. We know 2 square bracket x, that means 2 to the power 2x. So that's the 2 and x. Okay, so these two things, they can multiply together. Okay, so now you have the common base. The common base is 2. So we can compare the indices, okay? Because the base are the same, that means the indices must be the same, all right? So you need to solve this for x. So obviously, you can move that x to the right-hand side to become 2x minus x. And we know that 2x minus x just x. So that's just x equals minus 2, which is the answer. Okay, so let's quickly do another one. So the other one, left-hand side, the base is 3. 27, the base. Okay, so the base are not the same at the moment, but we know that 27 can be rewritten as 3 to the power 3, right? Okay, and so we can rewrite the right-hand side into 3 to the power 3 and bracket to the power x minus 1. Okay, right, so the second line, there's nothing changed to the left-hand side, but on the right-hand side, you need to be careful because there's x minus 1. When you try to remove the bracket, some people will make a mistake. Okay, remember this 3, you need to multiply both x and minus 1. So if you just write 3 to the power 3x minus 1, then obviously this is wrong. What you need to do is to have minus 3 after 3x. Now you have the same base and you can compare the indices, all right? And so it becomes 2x plus 1 equals 3x minus 3, right? Then, of course, you will try to move the number minus 3 to the left-hand side, becomes plus 3. You move 2x to the right-hand side, becomes minus 2x. Okay, so it should be plus 4 on the left-hand side, x on the right-hand side. So let's just write x equals 4, which is the answer. Okay? Okay, so let's see a few tricky ones. Okay, for the first one, 1 over 2 to the power x minus 1. So that's one of the thing. Let me remind you one index law. 1 over a to the power n is always equal to a to the power minus n, right? So that's what we call the negative index law. So in this case, what should we do? You should do 2, okay, because that's x minus 1 as a power, so 1 over. So is that correct? Okay, give you 3 seconds to think. Is that correct? Okay, 1, 2, 3. Okay, that's not correct. You need a bracket here. Okay, how about on the right hand side though? So that's 64. Okay, to the power x minus 2. I know that's looks a bit weird. That that's x over 2 is the power. All right. So how about that 64? 64 is 2 to the power 6. Okay, so let's just change that to 2 to the power 6 because we need that common base as 2. Okay, that's x over 2 is the power. Okay, then next, of course, you try to get that minus into the bracket. So you remove the bracket, then the second one must become plus 1. How about the right hand side? That becomes 6 times x over 2. When 6 times x over 2, it should be, okay, should be 3x. All right, so let me write the 3x there. Okay, so you have minus x plus 1 equals 3x. So again, I'm going to move that minus x to the right hand side, becomes 4x. Then move that 4 to the left hand side, becomes division 1 over 4, so x equals 1 over 4, which is the answer, right? And we know that's those drafts, so just cross them out in the examination. Okay, and how about the next one? Okay, it's similar one. You will see that's 25 to the power x, but it's being 1 over it, okay? And that's 125 to the power x plus 1. All right, first of all, let's try to, try to use the negative index law. Okay, and how about 125? At the moment, I just keep it. Okay, now it's 25, 125. Can 125 be expressed as a power of 25? Yes, but not directly. So you need to think about any common base for 25, 125. Obviously, that 25 is 5 square, right? How about 125? 125 is 5 cube. All right, so let's rewrite that as 5 square minus x. That's 5 cube. Bracket x plus 1. So that's 5 to the power minus 2x. So 3x plus 1. Again, 3 seconds. Anything wrong here? 1, 2, 3. Can you see that? You miss a bracket here, right? Or you can just change that 1 to 3. Okay? So now you can compare the indices. All right? So this time I might try to move that plus 3x to the left hand side, becomes minus 3x, so that becomes minus 5x equals 3. So x equals 3 over minus 5. Okay, so that's it. All right, so we've done the 4 questions using the common base technique. All right, and how about exponential graph? Okay, so let's have a quick look what we've learned in the exponential graph. Okay, first of all, the feature of all the exponential graph is like, okay, I need to amplify this a little bit. Okay, we know that this is sort of an exponential graph. So for all the exponential graph, they will have a what we call horizontal asymptote. That's the graph will approach. sometimes it approach the asymptote. In this case, it's x-axis. When the x value becomes very, very negative, sometimes you approach it when the x value is very, very positive. All right. So that means we have two kinds of behavior. Okay. So if you still remember this thing. So it depends on actually the base. If the base is greater than 1, then you approach the asymptote when x tends to infinity. Otherwise, if the base is less than 1 but greater than 0, you approach the x-axis or the asymptote, all right, when x becomes negative infinity, all right? But sometimes we can also translate the whole graph upward by certain units, like this one. Okay, you can translate the whole graph upwards by 2 units. So by doing so, your your asymptote will be changed, becomes y equals 2. So that means the number after the exponential part of the function is actually the value for your horizontal asymptote. You need to remember this. Okay, so let's go back here. Can we apply our previous knowledge here? First of all, when you look at the graph, you need to find y equals ax plus b. So obviously, you need to get the a and b in the equation. How can we know that? So the first thing you need to know is that this b, okay, this b actually include that plus, all right? This plus b is actually what we call the position of horizontal asymptote. Okay, which should be y equals b, right? Okay, so let's see when we observe the graph, what's the horizontal asymptote. Okay, you see there's a line over here which the graph approaches towards the negative end of x. Okay, so that means this line, oh, it's difficult to draw a line. Okay, let me insert. Okay, so this line. Okay, use another color, possibly I apply. Okay, so this line is what we call the horizontal asymptote, which is sitting at y equals minus 2. So that means what? That means b equals minus 2. Okay, but you still need to find value of a. Before we are going to find the value for a, let's rewrite the equation now because we've found b. So let's rewrite the equation into y equals a to the power x minus 2, right? So how can we find the value of a using the information? So normally the easiest points you could get is the y-intercept. Okay, so this is a y-intercept. So y-intercept, you have x equals 0. Okay, then y equals minus 1. Can this point work? Let's see, all right? So you put x equals 0, minus 1. So a to the power 0 minus 1. Oh, unfortunately, you see that a to the power 0 becomes 1. Okay, so that means, okay, it's still true, but you can't find a because when you do a to the power 0, it just become 1. You lost the information for a. Okay, so that means it doesn't work. Okay, so in the examination, don't give up. Okay, go back to see another point, 1 and 1. Okay, so if y-intercept doesn't work, try another point. All right, so x equals 1, y equals 1, right? Let's try this point. Okay, so it becomes 1, a to the power 1 minus 2. Okay, so this time it works. We can move that 2 to the other side. So it's a to the power of 1 is just a. So a equals 3. So we've got a, right? Okay, this is just one of the way to find the value for a and b in by using exponential graph. Okay, we have another one. When you compare question 5 and this is also question 5. Actually, they should be question 6, but it doesn't matter, right? So when you compare the graph in green and this graph in purple, you see they are a bit different. Okay, for the purple graph, the graph approaches to the horizontal asymptote when x tends to infinity on the positive end of x. So we will expect to see a different types of value a here. In the previous case, a is 3, which is greater than 1. So you should expect to see the a for this graph should be less than 1. So let's see. Right, first of all, can we find the asymptote? Yes, the asymptote is just right here, right? So this is the horizontal asymptote. Okay, all right, so here it is my, so that's 4, so this should be 1, right? So it should be 1, y equals 1. And we know that this value b is the position of horizontal asymptote. So let's just say b equals 1, okay? So our graph becomes a to the power x plus 1. You still need to find a. So what kinds of point are we going to use? So last time we tried to use y-intercept, but it doesn't work, right? So this time we know, okay, if you try to use y-intercept, the x becomes 0, then a to the power 0 becomes 1. So no matter what value of a it is, so it's not going to work. So let's use this point. Okay, x equals minus 1, y equals 6. Let's see what happens. So I put y equals 6, a to the power minus 1 plus 1. Okay, so, and you, of course, you move that plus 1 to the left-hand side. How about a to the power minus 1? It's just 1 over a if you want. So it's just 5. Okay, 1 over a equals 5. Okay, some of you might see that a is just 1 over 5. But if you can't see it, you can move that a to the left-hand side. Then you move the 5 to the right-hand side. So a becomes 1 over 5. It's done. Okay, so I'm going to take a break. And after this, I'm going to finish the rest of the revision exercise. See you later.